So today we're going to look at a video with structures of graphs. We've been kind of identifying structures of graphs with all the discussions we've had around zeros. Right now we're going to look at whether an odd or even degree polynomial function affects the graph in any capacity. So as I look at the first problem, it says sketch the graph of x squared, x to the fourth, and x to the sixth. And I would identify 2, 4, 6, and the rest of the numbers as even numbers. So as I'm going through this, and I kind of know the points, I'm going to do 0, 0, and then 1 squared is 1, negative 1 squared is also 1, 2 should graph out to 4, negative 2 should also graph out to 4, 3 should be 9, and negative 3 to 9. And we come really close, so 4 is out here at 16. You really want to stay on your graph as much as possible. And so around, if you can make this a nice smooth graph, it would be really beneficial to you. And hopefully you notice the shape looks somewhat like a U. You have seen quadratics before. And so now I'll graph x to the fourth. So x to the fourth is 0, 0. 1 to the fourth is also 1. And then 2 to the fourth is 16. Negative 2 to the fourth is also 16. And so now I'm going to do this in pink. I sort of have to follow this same pathway initially. It's a little bit beneath from 0 to 1. A little bit beneath here, but then it shoots up. And so that's what 2 to the fourth looks like. And then the 16th, and then x to the 6th power, well, 1 to the 6th, and then 2 to the 6th is way up to 32. So this is going to be more of a sketch, but hopefully you're going to realize, it goes through the 1 and then goes almost straight up. And so that's x to the 6th. And ultimately what we want to realize is that all of them have these end behaviors that sort of point in the same direction. And so I can generalize in the notes on even degree polynomials as when a degree of a polynomial is even, 2, 4, 6, 8, etc., the end behavior will be in the same direction. So it'll be towards positive infinity, or it will go towards negative infinity. So in words, both will trend to positive infinity as seen left, or both will trend to negative infinity. A couple examples could look like this, and you can see that they're both going down, and that downward be towards negative infinity. Okay. Example number 2 asks us to analyze odd degree polynomials. And so as you're looking at this, the sketch of the graph, you've got, again, like an x cubed, an x to the 5th, and an x to the 7th. And so as I sketch these, I can spread this out again for you guys. 1 here, 2, 3, 1, 2, 3. The initial point for x cubed, we'll go through 0, 0. At 1, it'll be equal to 1. Let's just scale this out real quick. 3, 4, 5, 6, 7, 8, 9. And the same would go down. So 0, 0, 1, 1, negative 1, negative 1, and 2, 8. And negative 2, negative 8. And so your graph gets this sort of S look to it. Flattens out at 0, then kind of trends upwards. And what I notice about this is that this sort of trends towards a negative infinity at the beginning on the left-hand side, and this trends towards positive infinity. And so they're going in opposite directions. And that's a little bit different than what we had seen with the even degree functions from before. And then we can look at x to the fifth, which is really just going to be, again, this is going to be a little bit more of a sketch, but it's going to go through 1, 1, 1, 1, and then it's going to go like shoot straight up very, very quickly. So it kind of looks like this. It's a little bit beneath and then goes really quickly. And I'm losing my reliability on my sketch just a little bit because it's really kind of estimates since it doesn't have nice points. And so this is going to be, it's slightly beneath here, and then it goes up, slightly beneath here, and it goes down. And finally, 0 to the 7th, so this one goes really straight right away. And ultimately what I'm trying to identify is the fact that the end behavior is going in opposite directions. And so if I were to write this up, when the degree of a polynomial is odd, 1, 3, 5, 7, 9, the end behavior will go in opposite directions. And again, what I mean by that, it could start off on the left-hand side here, down at negative infinity, but eventually it's going to go towards positive infinity on the right-hand side. Something else could occur. It could start up at positive infinity on the left-hand side, but eventually on the right-hand side, it will trend towards negative infinity. And so hopefully you can see how these are opposites. And this is the general understanding that when we have a degree, an odd degree polynomial, you'll have opposite results at the end behavior, and when you have an even degree function, you'll end up traveling in the same direction. So you get to a problem like this, and it says, consider the following function. And we were working with really, really basic functions at first, but this is x to the fourth plus 2x cubed minus 5x squared plus 3x plus 4. And so what the question is with a mixture of odd and even terms. And what they mean by that is like, here would be an even, here's an odd, here's an even, here's an odd, right? Predict whether the end behavior will act more like an odd or it will act more like an even. And ultimately, what determines this is the lead degree. So if it's a fourth degree, if you label this as a fourth degree polynomial, it'll act like an even degree. And that would tell me that the end behavior will be exactly the same. And what it looks like in between isn't what we're looking at. So you could go on to Desmos, and this function will go kind of in between 4 and 5. So here's negative 1, negative 2, negative 3, negative 4, negative 5, and kind of goes in between the negative 4 and the negative 3, and kind of comes back up really close to negative 1, between negative 1 and 0. And the graph looks a little bit like this, if you're to use Desmos. Flattens out, comes a little down, and then goes right back up. This goes down off the screen and kind of pops up over here. Very steep. And you can sort of get lost in the way you're drawing your graphs. But remember, what the question was really asking is, what do you notice about the end behavior? And what I noticed about the end behavior is that they're both traveling in the same direction. The reason why you're doing that is because it is an even degree polynomial. Okay, pause, reflect. Thank you for your time.